Leaving Cert Ordinary Level 2021, Paper 1, and this is question 7. Now this is the start of section B, so these are the slightly longer questions. You can see this question is worth 50 marks. Joseph is doing a training session. During the session, his heart rate, Hx, is measured in beats per minute. For part of the session, h of x can be modelled by the below function. Okay, x is the time in minutes from the start of the session. Complete the table below. I have all the calculations done out here for 0, 2, 4 and 5. So I'll just talk through one of them. I'll just talk through when h is 4. Okay, so effectively what I'm doing is I'm just subbing in x is 4, x is 4, and x is 4. So you can see that happens here. And all my numbers are calculated out over here. Add them up, and I have done it to the nearest whole number, as the question says that, to the nearest whole number. So 175 was the number that I got there. Again, you can see all the calculations for the other numbers. Okay, so that's the first part of the question, and the second part of the question is draw the graph using these numbers. Okay, so to take from here, we've got 0, 158. These are my answers here. So 0, 158. For 2, I've got 165, 4, 175, and 5 is 175 as well. And obviously there are more numbers in the table as well. 1, 160, 3, 171, and 6, 169. So you can see they get plotted there. They're the little pink spots there, and I drew the graph as we could there. Now the important part about it was that to make sure as well that the top part up here, just get a different colour for a second, is in fact a U shape. That's a bit of an exaggeration there, but we can see from the function that it is an x squared function, or even an x cubed function, so that these graph, it is important that this is like a U shape, and as it goes over here there'll probably be another U shape as well. So, you know, keeping in line with the cubic graph there. Okay, part B of this question. Explain what the coordinates of the point A, which is 6169, represent in the context of Joseph's heart rate. Okay, let's have a look at what we have here. So his time in minutes, so 6 minutes, and the rate over there is 169. So basically after 6 minutes of exercise, his heart rate, his BPM, is at 169. Okay. Moving on to part C of this question. Okay, so using the same axes and scales, continue your graph on the previous page to show the following information. Stays at the same level for the next 2 minutes. So I'm just going to go with that there. So for the next 2 minutes, he remains at the heart rate of 169. So from the 6th minute, and then for the next 2 minutes, so at the 8th minute, he's still at 169. So you can see there, that's how that point comes there. I've just joined along there with the green line. And the next part there, decreases at a steady rate of 10 beats per minute for the next 2 minutes. Okay, well, he's at 169, so after 8 minutes, so a minute later, decreases, he's going to be at 159. I just basically just take away 10, and then another minute later, 10 minutes, he's going to be take away another 10 at 149. So again, just to draw lines from 149 across there, approximately the same if I just shove this line up here, approximately going across from 159 there as well. Okay, so that's, again, the question said it was a steady decrease, so I made sure that it was a line on my graph. Okay, part D of this question. During his training session, the number of calories per minute that Joseph is burning after X minutes can be modelled by C of X, where H of X is Joseph's heart rate. So you sub in, if we're being asked about his heart rate, you can sub in for H of X. Use this information in the table or graph, work out C6. So we can sub in here H of X, this is his function for his heart rate, and for after 6 minutes we can sub in for each term X is equal to 6. So you can see me doing that there. And again, a good bit of calculator work here, guys, in this middle section here to give you 169. So 0.1 times 169 is 16.9, minus 7 is 9.9. Now you can also see mentioned there that if I just highlight this here is from up above, the very first thing that we're to do in this question, and subbing in 6 into that. We didn't actually do it, but for example, it's there when X was 6 and the answer was 169, so we could have just used that, or else used it to check that we were right. So that's all that I'm just mentioning there in the greeting writing. Okay, we'll move on now to part E of this question. Joseph has a smartwatch that beeps every 15 seconds during the session. It beeps for the first time at exactly 2:55 p.m. as Joseph starts his session. It beeps for the last time at exactly 3:23 as Joseph finishes his session. Work out how many times in total the smartwatch beeps. Okay, so I just kind of did this out. I just kind of wrote it out as I did it in my head. So at 2:55 until 3:23, there's basically 5 minutes up till 3 o'clock and then 23 minutes after 3 o'clock. So altogether that's 28 minutes. It beeps 4 times every minute, because every 15 seconds. So at effectively right on the minute, in other words, as 0 seconds passed, and then at 15, 30 and 45 seconds. The next minute will start at 0, in other words 0 seconds, and so on and so forth. So the last minute for 3:22 has the last beep at 3:22 and 45 seconds. So we obviously need to add in an extra little beep for 3:23. Now again, it won't beep at 3:23 and 15 seconds, so just the once there. Effectively, this minute only has one beep, as I said. So every minute has 4 beeps, and as I said, the last minute there, which is 3:22, so it's going to beep at 3:22 exactly, 3:22 and 15 seconds, and 30 seconds and 45 seconds. So they're the 4 beeps for the minute that is 3:22. That brings us up to 112 beeps, or 112 times, and then the very last beep plus an extra one for 3:23, as in the time 3:23. So all in all there's 113 beeps. Kind of an unusual question to see. I certainly thought it was anyways, but they stuck that one in. Okay, solve this equation. Now, previously up above we've seen hx. We've been working with hx up here. And all of a sudden the actual exam paper they haven't asked us to differentiate, they have differentiated this, and now we have to solve it. Okay, how do you solve an equation like this? A, B, C, minus B formula. See over on the left hand side of the screen there, I've written the formula and ABC, and I'm subbing in here. Okay, so it's minus B formula, so that's minus 5.2 plus or minus square root of b squared minus 4 times a times c all over 2 times a. And the rest of this question is just calculator work. I always tell people to start in here, do that part first, and then you're talking 5.2 squared minus that number or plus that number, whatever the case may be. This is all just calculator work. Okay, just skip over to the other side of the screen there now. So we work, this is the number we worked that out to be, and then square root of that number there. This is how you get, I feel, how you display it most accurately to the examiner, that you know how to use the minus b formula. Okay, when you get the square root of this, 5.143, at this stage now you go one side on the left hand side for your plus, and on the other side with your minus, so as to show them how you're getting your two answers. Now just flicking back to the question again, give your answer to 2 decimal places. Okay, so this answer here, we can see from the graph that his heart rate is not at a maximum BPM after this number here. So this answer, 4.536, which I'm going to round up to 4.54 seconds. This also corresponds to the graph. That's just an extra note added in there for people that were aware that this would relate to the maximum when it's equated equal to 0, but we weren't really asked to comment on any of that, and there's nothing there in the question that says your answer is not equal to something or the other. So both of them would be fine to give, just to give them as to 2 decimal places. So we might go with 0.03 on this one, and this one would be to 4.54. Okay, that's the end of this question here.